Okay, here is your screencast to help you with your MarshallowCalorimetry lab report. We worked on the first tab of this spreadsheet in lab today, but just to refresh your memory, we decided that we had in our first trial 25 grams of cool water, 25 grams of warm water, because we know the density of water is 1. If we know the milliliters of water, we know that the grams are also the same. Now, this spreadsheet is not giving me the right number of significant digits. Let me make it bigger. And so if you go up here, you can have an increase or decrease decimal. So I'm just going to select both of those boxes, and I'm going to add another decimal to both of them because we do know that to the 10th place. So then your total mass of water is just adding those two together. You could also use the sum function if you wanted to do that. The temperature of your cool water and the temperature of your warm water, that is from your data. So I'm just going to put a couple numbers in that will not match your data, and that's fine. And then the theoretical temperature of your final water. Remember, this is a weighted average. So half of our water was this temperature, half of our water was this temperature. So the way that we're going to do that using Excel is open your parentheses. We'll do our cool water first. So the mass of my cool water divided by the total mass times the temperature of the cool water. And then I'm going to add that, open your parentheses, to the mass of the warm water divided by the total mass, close parentheses, and multiply it by the temperature of the warm water. You can pause this screencast at any time to put the formulas in. I'm hitting enter. These had 4 digits after the decimal, so this one should also have 4 digits after the decimal. Our actual experimental final temperature, again, this is something that you recorded from Microlab. I'm just making up a number. So this is your data here. And then your relative error, the formula is right here. So just open parentheses, experimental minus theoretical, close your parentheses, divided by my theoretical, and then we're doing this in parts per thousand. If it was a percentage, a percent error that we were trying to find, we would multiply by 100, but we're doing it in parts per thousand, so I'm going to multiply it by 1,000. This has way too many significant figures. I should have a total of 6. So I'm going to go up here and make sure that I only have 6 total. Specific heat of water in calories per grams times degrees Celsius is 1.000. And we're going to have to go back and give that enough sig figs. The heat change, so this is that formula that I showed you on the board. Heat equals mass times specific heat times change in temperature. So for my cool water, here's my mass times the specific heat times the change in temperature. So the final temperature was this, and then we're subtracting the initial temperature of the cool water. Remember, this is an endothermic process. The cool water is absorbing energy. Therefore, you get a positive number for your answer. Because this only has 4 sig figs, row 19 can also only have 4 sig figs. So we will change that. And then finally, for heat change in warm water, it is mass times specific heat times change in temperature. This is an exothermic process. It is releasing heat. And the way that we show that mathematically is by having a negative sign. So your answer will be negative, and that is okay. So you are going to do the calculations for this using the 10 and 40 milliliters or grams of hot and cold water, and then you also did a 40-10, and then you picked something. Oh, you can't see that because I got to move this down here. So you did a third trial and a fourth trial. So there's not as much detail down here as there is up here, but it's the same idea. Do not worry about the planned columns. I'm not worried about that. Okay, so just put your 4 trials in there. Okay, moving on to the calorimetry tab really quick. Please make sure that you fill this out. Name, section. We are 128-07. And on your heat capacity, I'm pretty sure, yeah, it's up there too. So please don't, remember to get your name on there. Okay, so for trial 1, 1.000 is the specific heat of water. And again, we are going to have to increase our decimals. The volume of water that we used every time that we put it in our can when we burned the marshmallow was 50. So the mass of water, because the density of water is 1 gram per milliliter, the mass of water is also 50. So heat capacity, that's your big C, is mass times specific heat. So mass times specific heat. I'm going to lose my mind because none of these have the right number of sig figs. Okay, let me scooch this over. Sorry about that. Mass of watch glass plus paperclip, mass of watch glass plus paperclip and food, and then final mass. So this is after we burned it. So I'm going to pause for a second and punch those in. Okay, so this data, you have this in your notebook. So I just put in some data from my notebook or scrap of paper that I wrote it on. So your initial mass of food is just your mass of your marshmallow, watch glass, and paperclip minus the watch glass plus paperclip. The final mass of food is after you burned it, minus what you had at the very beginning. And the change in the food mass is the B15 minus B16. So that's the change in the food mass. I'm going to bring this down here now. Average initial temperature, this is what you measured from microlab, so I'm going to pause again for a second and throw in my data. Okay, so here's my data. Your data is going to look a little different. So change in temperature, you're just looking at your final temperature after you burned your marshmallow minus your initial temperature. The uncertainty, this is where we have to use that crazy formula. So it's equals square root, open parentheses, select your standard deviation for your initial temperature, hit the caret key, which is right above the 6 on your keyboard, and put a 2 because we're squaring it, and then plus the standard deviation for your hot water, caret 2, so that we're squaring it, close parentheses. And I'm going to hit enter. This should only have 4 sig figs, so I'm going to hit 4 sig figs there. So then the heat gained by the water, this is very similar to what we did on the other tab. It's mass times specific heat times change in temperature. So equals the mass of my water, which is here, times the specific heat of water, which is here, times the change in temperature. So I ended up at 29.8765 minus my initial temperature. Close parentheses, hit enter. What is that heat per mass of food? It's just what I just calculated divided by the initial mass of food. And again, I should only have 4 sig figs there. Okay, so my mistake in this cell B28, you actually need to divide by the change in the food mass. So this is how much of the marshmallow actually burned. And so when you go to B28, it should be B27 divided by B17. So then you will put in, oops, hold on, erg. Okay, so once you get all your other data in here, you can actually click and drag all of these formulas across. So that makes it really handy. You can't do that in the blue boxes, but you can do it in the red boxes. And then when you come down here, your formulas are average of these 3 values right here, close parentheses. And then you're going to do standard deviation of these 3 values. And once you actually get numbers into those cells, this will show up. And then finally, we're converting it to food calories. So you're just going to take the value that you got up here and divide it by 1,000, because a food calorie is 1,000 times a calorie that we measured in lab. And so that's your spreadsheet. So let's just quickly go over what you need to do for your lab report. So for your mini report, hard copy of the heat capacity spreadsheet, hard copy of the calorimetry spreadsheet. So really, you're just taking this and you're printing out the 2 tabs for me. And then you're going to upload it to the link that is right here. You also need to have a hard copy of your microlab temperature versus time plot. So you can, the 2 that we saved in lab, I just need a copy of the graph. If you have questions about how to do that, just let me know. Sample calculations for cells B14, 16, and 19 from heat capacity, and C24, 27, and 28 from the calorimetry tab. And so as an example of sample calculations, I put that onto Moodle, and you can find it there. Let me move this over. Here is a sample calculation for cell B14. You can either put these in your lab notebook or you can do it on a white piece of paper. It does not matter to me. But these are the basic parts of it that I need to see. I need to see a math calculation using your numbers. I need to see an answer with units. I need to see cell numbers from the spreadsheet. Okay, finally, you'll have to tear out the carbon copy pages from your notebook and attach those to your lab report. And then you also need to type up answers to these questions, which I will send out in an email. If you have any questions, let me know. Otherwise, have a great weekend and a great week, and I'll see you on Thursday.